So today's objective is to understand the surface area of a cuboid and a cube. Let's look at these objects seen in these pictures. Each of these objects have 6 faces that are rectangular in shape. Now, such objects are called cuboids. Now, if you look at these faces, the top and the bottom faces are parallel to each other. These are called bases. The remaining 4 faces that join the 2 bases are called lateral faces. Now, cuboids have 8 vertices and 12 edges. The edges of this cuboid are its length, its breadth, and its height. Now, let's look at another figure. Now, in this figure, the length, the breadth, and the height are all equal. Now, such a figure is not called a cuboid, it's called a cube. Now, as you can see, the basic difference between a cuboid and a cube is the shape of the faces, right? For example, the cuboid that we just saw earlier has rectangular faces, while a cube has square faces. That's the major difference between a cuboid and a cube. A cuboid has rectangular faces, while a cube has square faces. Now, these figures are also known as prisms. You must have heard about prisms, right? Now, let's look at a practical problem. For example, say you want to put up a wallpaper in your room, right? And you need to estimate the number of wallpaper rolls required, right? For this, you need to know the area of the 4 walls, correct? Now, as you can see, the room is cuboid in shape. They are not squares, they are rectangles, and hence a room is cuboid in shape. Now, the 4 walls of a room represent the 4 lateral faces of a cuboid. Correct? Because the wallpapers are not going to be put on the ceiling and the floor. They are actually the lateral faces. Now, if we add the area of the lateral faces, what we get is called the lateral surface area, or the LSA of a cube. Now, let's derive a formula to calculate the LSA of a cube. To calculate LSA, we have to find the areas of the 4 lateral faces. Now, like I said, this is a cuboid and hence it's not a square, it's a rectangle. So as each lateral face is a rectangle, we can apply the formula length into breadth, right? To calculate the areas, because that's the area of a rectangle, length into breadth. Now we get the areas of each lateral face as length into height, breadth into height, length into height, and breadth into height. That is LH, BH, LH, BH. This was very easy. Calculating LSA was very easy. All you needed to do was add all these areas. Now, on simplifying this expression, we get the formula as 2 times height multiplied by the sum of the length and breadth, right? That's how you simplify this equation. Now, let's rearrange this formula here, to see that twice the sum of length and breadth is equal to the perimeter of the bases. Correct? The perimeter of the bases is nothing but is twice the sum of the length and breadth. Hence, we can also define the lateral surface as the product of the perimeter of the base and height of the cuboid. Once again, the product of the perimeter of the base and height of the cuboid. Right? Now, using this formula for LSA, we can also derive the formula to calculate the LSA of a cube. This was a cuboid. Now we'll derive a formula of a cube. Now, in case of a cube, all its edges are of the same length. They don't have a length, breadth, height as different measures. They have all the measures are of the same dimension or the same length. Let's assume it is A. Now, substituting A in place of L, B and H. The formula becomes very simple. it is 4a square, right? It becomes very simple by just substituting a in place of L, B and H. Now consider a different situation where you have to paint an overhead water tank. Now in this case, you need to find the total surface area or the TSA of the tank. In case of wallpaper, it was just the lateral surface area. But when it comes to the entire tank, painting the entire tank, it is the total surface area. Please note that the tank is cuboid in shape. It's not a cube. The total surface area or TSA of a cuboid is nothing but the sum of lateral surface areas and the area of the two bases, right? Now please note that the areas of the bases are equal, that is equal to twice the length into breadth, right? We've already derived the formula to calculate lateral surface area. Now all we have to do is substitute these in the equation and simplify it. On simplifying, we get the TSA of a cuboid is equal to 2 into LB plus BH plus LH. Once again, 2 into LB plus BH plus LH. We can use this formula to derive the total surface area of a cuboid too, and a cube, right? In case of a cube, like we mentioned earlier, the length, the breadth and the height all are equal. So let's again assume that A is what we represent L, B and H as, and just substituting A in place of L, B and H. Now we get the formula for total surface area of a cube as 6a square.